Okay, so we're given this table of values, and basically what we're trying to do is find out what degree it is and what the value of the leading coefficient is. So to do this is actually quite simple, to be honest. We're going to have to do the first, second, and third, and however many finite differences there are until we find a constant value for the finite differences of all of these. So we're going to do 221 minus 105. And we're going to keep doing that for all of the y values. So 221 minus 105 would be 116. Then 105 minus 37 would be 68. Yeah. And then 37 minus 5 would just be 32. And then 5 minus negative 3, which would be adding, it would be 8. And then negative 3 minus 1 would be negative 4. So that's what we have for our first finite difference, or first finite differences. So you could write it as first differences, or you could write it in change in y. That's just a delta. It just means change. Change in y1. It doesn't really matter how you write it. But those are just different ways that you might see it and what it really means. So 116 minus 68, and we're going to keep going until all of these numbers are the same. So 116 minus 68 would be 48. 68 minus 32 would be 36. And 32 minus 8 is 24. 8 minus negative 4, which is just adding, it would be 12. So these are our second differences, or our second change in y. Then we're going to do it once more. We're going to go further. So we'll do 48 minus 36, and so on and so forth. And we basically find out that these differences are all equal to 12. So the value of the third differences would be 12, positive 12. So we know that the value, which is v, is equal to 12. So what does the finite difference tell us? This tells us if it's constant in the third finite differences, that means that it's a third degree function. So if it was constant values in the second finite differences, then you'd know that it would be a second degree function. And then if it was the fourth, it would be a fourth degree, and you could probably guess what it would be if it was a fifth degree function. So we know that this we can call n equals 3. So then we use this equation to find the value of a, which is the leading coefficient. We can do v equals a n factorial. And factorial looks really fancy because it's an exclamation point, but it's actually really easy. It just means, I'll explain what it means once I substitute it in, because it's going to make no sense. So 12 would be equal to a, and then the n is 3, so it would be 3 factorial. So 3 factorial basically means just 3 times 2 times 1. So if it was 4 factorial, it would be 4 times 3 times 2 times 1. So we know that this, 3 times 2 times 1, that's just going to be 6. So 12 equals 6a. And now we can just simply just isolate for a. So 12 divided by 6 simplifies down to 2. So the value of a is 2. So therefore, given this table of values, we know that the degree of the function is third degree, and then the leading coefficient is positive 2.